inequalities with the word and. Okay? Whenever we have a compound inequality connected by the word and, we're going to use intersection. Okay? Something like this, just some quick examples. Suppose we have x is greater than or equal to a negative 3 and x is less than or equal to 6. Okay? So from last week, let's graph both of these. Just to use my fat marker for this one. So negative 3, there's a 6, there's maybe a negative 3 there, there's a 6. So if x is greater than or equal to negative 3, it includes the negative 3, so that's a bracket, and it's bigger, so it's going to be all of this, right? Now if x is less than or equal to 6, again there's a bracket on the 6, but it's got to be smaller, so it's going to be all of that. Okay? Now notice that this is the solution, or just the graph on the number line of this thing. This is the solution of this thing. The solution to the compound inequality is the intersection of these two. So if we could imagine picking this graph up and putting it on top of this one, where would the two be intersected? So to do that, I'll just draw them again on the same graph, negative 3, 6. So negative 3 all the way over there, 6, and all of this. So then what's the part that's the intersection of these two graphs? So it includes the negative 3, okay, because the bracket means it includes that number. This number, negative 3, is in red and it's also in green. All of this in the middle is both red and green. And then also the 6, that's an ugly 6, is also in red and green, and everything in the middle. Okay, so just to demonstrate, this is the actual solution to that compound inequality. And that's the kind of thinking that you'll have to do to write down the solutions to these things. You can graph each one separately if you want. If you want to graph them together, that's fine. But you want to, whenever they're combined with an and, you end up taking the intersection of the two graphs. Are there any questions? Let's do one more example. What about this one? X is less than 0 and x is bigger than 0. You may not even have to graph this one. Just think about it. So can I pick any number x? And that number is going to be less than 0, which means it's going to be negative. And that number is also, at the same time, going to be bigger than 0, which means it's going to be positive. Are there any numbers that are both negative and positive at the same time? No. So there's no solution. Now you can graph it if you want, but just another way just to even think about it. There is no solution here. Just to see the graph quickly, it might look like this. For this one, x is less than 0, so it's a open parentheses, does not include the 0, goes this way. X is bigger than 0, again it's open, so it does not include the 0, and it's going to go this way. Okay, now you may think that because these red and green meet up right here at the 0 that they intersect right there. But remember, these open parentheses means you do not include that point 0. So there is no intersection, and hence there is no solution. Yes? If it were greater than or equal to, it would still not have any intersection, because it wouldn't be, 0 would be in one, but it wouldn't be in the other. Now, if they were both less than or equal to and greater than or equal to, there would be an intersection. So I can show you that one. Is this the one that you're asking? Something like that? X is less than or equal to? Yeah, that's a good example. Let's look at it. So for this one, it would include the 0. Again, for this one, it would also include the 0. So what is the intersection? Just 0. So the answer would just be the point, or the number 0. Just that point 0. Because that point 0 is both included in the red, noted by this bracket, and included in the green, noted by this bracket. You had your hand up too. Okay, cool. Yeah, great examples. Any other questions? One more example. This is more like what we're probably going to be seeing. This was example 3. Here's example 4. X plus 3 is less than or equal to 2x minus 1, and 3x minus 2 is less than or equal to 5x minus 4. Okay, so before we can even start to do any graphs or number lines, what are we going to have to do with these guys? Yeah, isolate x, solve them for x. So everyone take a minute and do that. Subtract, add, I'm getting, and then do that. Did I make any mistakes? Is that what you guys got? So this one, x is bigger than or equal to 4. I make mistakes, so if you didn't get that, let me know. And over here, that's what I got. Subtract 2x, added 2, added 4, get 3, divided by 2. Okay, now let's look at how were these inequalities compounded together? And so we're going to do the intersection. So let's look at the intersection of this. So x is bigger than 4. Let me put 1 and 4 on my number line. Now it's important, remember to, when you do write numbers on your number line, you've got to keep it in the conventional order. The numbers get bigger going to the right and smaller going to the left. For this one, x is bigger than or equal to 4. For this one, x is greater than or equal to 1. Okay, so what is the intersection of those two number lines, those two graphs? So the intersection is everything that's both in red and in green. What's that? What to infinity? Well, 1 is in green, but it's not in green and red. You're on the right track, right. The 4, now is the 4 included in both the red and the green? Yes. So I want to graph it, and it's 4, and it goes all the way out to infinity. And so then what is the interval notation? We did this on Thursday. Bracket 4, comma, infinity, open. Just to make it pretty, I'll put that in red there. Okay, so let's look at all the different types of solutions we had. We had one solution that was bounded on both the left and the right hand side, right? Okay, it stopped at one number on both the left and right. We had no solution. We had a solution that was just a single point. And we also had a solution that was bounded on the left-hand side, which means it stops on the left, but it also goes on forever on the right. Well, we can have another one going on forever to negative infinity. So there's all kinds of different solutions that you might come up with. So it's so important to plot these and look at their intersection. There's no way to just look at it and solve it. You have to kind of take the steps of taking these graphs and looking at that intersection. Any questions?